We are going to look at the volume formulas of three-dimensional shapes. So again, just like when we looked at surface area and we broke it down into prisms, pyramids, and spheres, we're going to do the same thing using our volume formulas. So volume is the three-dimensional space inside. Surface area was the area around a three-dimensional shape. Volume is within a three-dimensional shape. So it's in a cubic unit. So whether that's feet cubed or meters cubed or inches cubed, or even in sort of a capacity sense, it might be in milliliters or gallons or something in that format. So we'll go through the generalized formulas and then do some examples of it. So volume of prisms. So remember the definition of a prism was that it had two common faces that were both the same and was the same throughout that particular shape. If you have a prism, the volume is area times height, where A is the base area, where we can go into our formulas, and H is the height of the prism. So for example, a rectangular prism again, we might take a look at. And again, rectangular prism, you can really use any side to be your common face, but I'm going to use the bottom. So here could be our common face. And then obviously throughout we have the same common face on the other side, and then this would be the height of our prism in between. So the volume would be the space inside of it. So what you're doing is looking at the area of your base multiplied basically by your height. You could have a cylinder with the same thing. So remember, a cylinder can be considered a prism as well. So what we do is we'd find the area of the circle and then again multiply by the height of the prism. If you're looking at a pyramid or a cone, our generalized formula is area, so A times H divided by 3. So basically it's really just taking the volume of a prism and you're cutting it into 3. So very similar sort of style. So again, if you look at a square base pyramid, for example, or a rectangular base pyramid, it has the apex along the side, and then what you're really just doing is you're looking at the area of the base, multiplying it by its height, which would be more like the altitude, not the slant height. The picture not very nice. And then dividing it by 3. So a cone, for example, is the same thing. So you have your apex up here. So what you'd want to do is you'd want to find the area of your base, which in this case would be a circle, multiplied by your height or your altitude, your perpendicular height, and then divide by 3. Sphere, you actually have a formula related, again, just like we would for surface area. We have a formula for radius, and we have a formula for diameter. Notice that it's cubed in this case because, again, we are dealing with a three-dimensional space. So again, in a cubic situation, we would actually be looking at the radius being half of the diameter, or diameter all the way across.